Let's talk about every cloud architect's worst nightmare. An entire Azure region just goes dark. Your apps, your data, poof! It's a scary thought, right? Well, today we're going to build the blueprint for cross-region disaster recovery in Azure. So you're not just crossing your fingers and hoping for the best, you're actually prepared for the worst. So here's how we're going to tackle this. First, we'll get our heads straight on why this is so important, the inevitability of an outage. Then we'll get into the basic building blocks, the foundational patterns. After that, we'll see how to assemble those into some really powerful architectures, watch one in action, and then, to wrap it all up, I'll give you a framework to help you choose the right strategy for your own situation. All right. First things first, we have to start with a really critical mindset shift. See, regional outages aren't a question of if they'll happen, but when. And honestly, treating your disaster plan as a core part of your design from day one, that's what separates the pros from the amateurs in cloud architecture. No, really stop and think about this for a second. If the Azure region that hosts your entire application just blinked out of existence right now, what happens? Is your business completely offline? How long would it be down for? And the scariest question of all, how much of your data did you just lose? Forever. This is exactly the kind of doomsday scenario we need to design for. So, to even begin answering those questions, we need to get familiar with two key metrics. The first is your RPO, or Recovery Point Objective. Now, this isn't about how fast you recover. It's all about data loss. It asks the question, what is the absolute maximum amount of data, measured in time, that your business can afford to just lose? So an RPO of, say, 1 hour means you absolutely cannot lose more than an hour's worth of transactions or customer data. This number basically dictates how often you need to be saving your stuff. And the other side of that coin is RTO, or Recovery Time Objective. This one is all about speed. The question here is, what's the maximum amount of downtime your business can tolerate before things get really, really bad? An RTO of 4 hours means you've got to be completely up and running in a totally different region within 4 hours of that disaster hitting. These two, RPO and RTO, they're going to be the twin pillars holding up every single architectural decision we make from here on out. Okay, now that we know our goals, our RTO and RPO, it's time to open up the toolkit. Let's start with the two most fundamental patterns, the real bedrock of any resilient system. First up, we've got the old classic, backup and restore. It's pretty much the simplest and usually the most cost-effective pattern out there. It really is the essential baseline for almost any DR strategy you can think of. So how's it work? Well, it's pretty straightforward. You take regular backups of your data and your configuration files, you copy those backups over to a whole different secondary region, and if disaster strikes, you spin up new infrastructure over there and restore from those backups. It's super reliable, but because you're literally rebuilding and restoring from scratch, you got to be prepared for a higher RTO and RPO. That means more downtime and potentially more data loss. All right, let's level up to our second pattern, which is a pretty significant step up, geo-replication. This is a lifesaver, especially for your stateful services, like your databases, where losing data is the absolute biggest concern. This is where using the platform's native features becomes a total game changer. Services like Azure SQL Database have geo-replication just built right in. It automatically and continuously sends your data to a secondary region. This absolutely crushes your RPO, bringing it down to just minutes or sometimes even seconds of data loss. Now, the failover itself might still be a manual button push, but trust me, promoting a replicated database is worlds faster than trying to restore a massive database from a backup file. So we have our building blocks, right? Backups and geo-replication. Now let's start putting them together into complete architectures that are designed to meet some much, much more aggressive recovery goals. The two big patterns you'll always hear about are active-passive and active-active. Think of active-passive, or warm standby, like this. You have a second region with a small, scaled-down version of your application just sitting there, ready to be scaled up at a moment's notice. On the other hand, active-active, or hot standby, means you have two full-scale, identical deployments running at the same time, and both of them are serving live traffic. This choice right here is the fundamental trade-off you're always going to make between cost and recovery time. Okay, theory is great and all, but let's make this real. We're going to walk through a practical example of the most common advanced pattern, the active-passive or warm standby model. We'll use a pretty typical web application as our example. So here's our sample app. It's a pretty standard setup, right? You've got a web front end, some APIs for the business logic, and an Azure SQL database holding all the data. But the real magic ingredient, the thing that makes all of this disaster recovery possible, is a global traffic manager like Azure Front Door. Think of it as the intelligent switchboard operator that can reroute all of our users based on which of our regions is healthy. Okay, so let's watch the failover happen. Boom! Disaster strikes the primary region. Immediately, Azure Front Door's health probes pick up on this failure. It automatically stops sending traffic to the dead region and reroutes every single user to our secondary passive region. At the exact same time, automation scripts kick in to scale up the web and API tiers in that second region so it can handle the full production load. The final step is to execute the failover on our geo-replicated database, making the secondary the new primary. And just like that, you're back online. We've seen the concepts. We've walked through a real example. Now comes the most important part. How do you actually pick the right strategy for you from all of these options? This decision matrix right here is your key takeaway. Seriously, this one slide lays it all out. Backup and restore, low cost, low complexity, but you get the highest RTO and RPO. The active, passive, warm standby, that hits a fantastic sweet spot. Moderate cost and complexity, but for a way better RTO and RPO. And then you have active-active, which gives you the lowest possible downtime. We're talking near zero, but it comes at the highest cost and complexity. You use this matrix to map your application-specific RTO and RPO needs to the pattern that makes the most business sense. And that really brings us to our final thought. As you look at these patterns, I want you to ask yourself a serious question. Is your current disaster recovery plan a well-rehearsed, documented, and automated blueprint for resilience? Or is it just kind of a hopeful afterthought, maybe tucked away in some document nobody's looked at in years? Because the difference between those two could mean the difference between a minor hiccup and a catastrophic failure for your entire business.